Welcome to Unit 1, Module 1, Lesson 1. Today we're going to talk about adding integers with the same sign. So after this lesson and after our work in class, I will be able to add rational numbers with the same sign, represent addition of rational numbers with the same sign on a number line, apply properties of operations to add rational numbers with the same sign, and solve real-world and mathematical problems involving addition with rational numbers with the same sign. So again, in your binder, you have your I can statements, and you would write down today's date, the one which you're watching the video, as the date taught, and then tomorrow would be the day that it was retaught, or the day that we're in class would be the day that it is retaught. So don't forget to write that down before you get started here. All right, so here we go. Right, so if we had counters in front of us, so these counters that you're seeing here, these little dots, each represent 1. However, the yellow counters represent a positive 1, and the red counters represent a negative 1. Well, if I have 3 yellow counters and I add 4 yellow counters, that is going to give me a total of 7 counters. And the reason that I have a total of 7 is because I'm adding the same things. I'm adding yellow counters and yellow counters. More specifically, I'm adding positive and positive. Right? So when looking at this, what is the sum and how did you find it? Well, the sum is 7, and I found it by adding the 3 counters and the 4 counters and getting a total of 7. Yes, I realize that I just accidentally typed 8. All right, so going all the way back to the basics, we know that if we take 2 numbers and add them together, we move up the number line. But now what happens when we bring these red counters into play? Right, so now we're looking at negatives. Well, in this case, we're looking at negatives and negatives. So again, we're sticking with, in this case, I'll say apples and apples since they're red, right? But we have 5 red counters plus another 3 red counters. So in this case, we know that there are 8 total. However, because of the fact that I added 2 negative numbers, my sum isn't a positive 8, it's actually a negative 8 because I'm on the other side of the number line, because each of these represents a negative 1. So it's not that I have a positive 8, I have a negative 8. Right, so in looking at our first reflect question, when adding 2 numbers with the same sign, what sign do you use for the sum? Right, so when I'm adding 2 numbers with the same sign, in this case I have negative and negative, and previously I had positive and positive, we can just say I would keep the sign of the 2 numbers. So if both signs are the same, I keep my sign. And that's something really important to remember here. When we're adding positive and negative integers, if the sign is the same, we keep the sign. So let's look at this in terms of temperature and kind of real life scenarios here. So the temperature was 2 below 0. Now the important part here is that it was below 0. Since it was below 0, I know that this means that it was actually a negative number. Okay, and then it drops by 5 degrees Fahrenheit. Right, so in this case, let's go through and actually do our close reading. So 2 would be an important number, and then below 0 would be important words, and 5 would be an important number, and the fact that it drops 5 degrees would be important. And then what is the temperature now is our question. So let's work towards finding that answer. So first, what is the initial temperature written as an integer? Well, since it's 2 below 0 tells us that it's negative. So I know in this case as an integer, it would be negative 2. Right? Well, on our thermometer, we can see here that it's a negative 2. On my number line, I'm going to mark that. And negatives, when we have a vertical number line, negatives go down. Okay, so -2 in this case would be here. Right, so now a drop in temperature of 5 is like adding -5. So yes, we're talking about dropping, and dropping means essentially taking away. But in this case, we're looking at it in terms of addition. So it's adding a -5 to the temperature. So we're going to count on the number line to find the final temperature. So it's dropping 5 degrees. So since it's dropping, it's going down. So 1, 2, 3, 4, 5. Now in this case, I know that when I drop it by 5, that it gets me to a -7. So now I know that the temperature is 7. And in this case, since it's negative, it is 7 below 0. So what we're going to focus on here, this is kind of the big part, or the leading into part here, explaining that when you have two integers that have the same sign, you add them together. Right, we're going to look at kind of how that works on a number line and why it works that way. Okay, so what if, suppose the temperature is -1 degrees Fahrenheit and it drops by 3 degrees Fahrenheit. Explain how to use the number line to find the new temperature. I want you to take a second, write down your answer, and then come back and check your answer. All right, to find my answer on a number line, to find my answer on the number line, I would first plot -1. Then I would count down or left, depending on the number line, 3 spaces. And that's all I need. I don't need to know what the answer is. I just need to know that that's what I would do. Okay, so you always plot your number first, and then because you're dropping, you know that that's a negative, so it's going down. How would using a number line to find the sum 2 plus 5 be different from using a number line to find the sum -2 plus a -5? So again, take a second, think about it, come back and check your answer. So here, we would be, in this case, it's different because we would start at +2, then go up 5, but for the other, we would start at -2 and go down 5. And actually here, I shouldn't say just go up 5, we would go up or right 5, and we would go down or left 5 on the number line. All right, so here, what are two other negative integers that have the same sum as -2 and -5? So we know that -2 plus -5, we know how to do that. If you need to, draw it on a number line, and when you come back, you can check your answers. So here you could have had -1 and -6. You could have had -3 and -4. You could have had 0 and -7. And that would be it. So two other negative integers, that's the important part here. All right, now I want to dig into this a little bit deeper. So I know that we have the example here, and it's telling us that when you're adding integers with the same sign, you just use their absolute values. And I want to look at why that works. So if you have a number line, and I'm going to quickly draw up a not very good number line here, but it'll work for what we need it for. All right, and in this case, my middle point is 0. There we go. So now here I have a -6 plus a -7 plus a -6. So let's say that I'm here and that's our -7. right? Well, the negative tells me that I'm going, and I'm just going to work with a horizontal number line first. Okay, so the negative 7 tells me that if I start at 0, I need to go to the left 7. A plus sign tells me then that I have to go to the right. But now, because I see another negative, that tells me, nope, I'm not going to the right anymore. Now I'm actually going to go to the left. And I'll actually make this an uppercase L. And I'm going to go to the left 6 spaces. And when I go to the left, I know that as I go down the number line, my numbers get further away from 0. So on the other side, it looks like, they're getting bigger. But remember, when we're on the negative side, it's actually getting smaller. And I'm actually getting further away from 0. And I get to negative 13 when I jump my 6 spaces. So 1, 2, 3, 4, 5, 6. So your signs tell you which direction you're going. That negative sign tells you that you're going left or down. And this would be something that would be good to write down. A positive sign tells you you're going right or up. Okay, and then when they are running into each other like this, whichever one is closest to the number pretty much tells you what you're going to do. So again, this tells me I'm starting 7 below 0, and then I'm going to add, but when I add, I'm no longer going to the right. I have to go to the left because of this negative sign, 6 spaces. All right, so that's what's happening on a number line when we do this. All right, so now we're going to look at, does the commutative property of addition apply when you add 2 negative numbers? Explain. Remember, the commutative property allows us to move our numbers around when we're adding and multiplying. So we're just talking about addition, so we can move our numbers in any order and get the same answer. Does that work when you're adding 2 negative integers? Take a moment, think about your answer, and then come back. So yes, the commutative property of addition still works with 2 negative numbers because we are adding the absolute values, which are always positive. And we know that the commutative property works with positive numbers. Right? So we could also say, and since they have the same sign, they go the same way on the number line. So again, since they're negative, it starts to the left, and then when you add to the left. All right, so number 6, choose any 2 negative integers. Is the sum of the integers less than or greater than the value of either of the integers? And then will this be true no matter what? So what they're saying is if I take -1 and -5, is my answer less than or greater than those integers? So is my sum less than or greater than -1 and -5? This is one I want you to try on your own. So I want you to have this answered for when you come back to class. All right, so here for this one, what I want you to do, I want you to try numbers 1 and 2 on your own, and then come back and check your work. If you're still really struggling, go through number 1 with me, and then try number 2 on your own. Okay, so in this case, even though they're both negatives, I know that there are 6 counters, and they represent negative numbers. So since there are 6 negative counters, my answer is, or my sum is, -6. Number 2, there are 9 counters. They're both red, so they represent negative numbers. And so I know my answer is -9. Okay, let's do number 3 together real quick. So remember, I'm going to plot my first number, so -5. So the negative tells me I have to go to the left of 0, 5 spaces. So 1, 2, 3, 4, 5. Again, that negative tells me to go left. The the plus tells me to go right. But then again, this negative tells me I'm actually going to go left. So I'm going to go 2 spaces to the left, which is -7. Right? I want you to take this opportunity to try the rest of them on your own, but I do want you to check to make sure that you're plotting them in the right spot and then going the right way. Please show your jumps on the number line, as this is really building into the next couple of parts. And actually, if you want to look at this, and I'd really encourage, if you're struggling, to start with this, the left and the right and the left. Get into that practice because it'll help when we go into numbers that have different signs. All right, now that you're back, you should have ended up with a left and a right and a left. You would have plotted at -1. You would have gone left 3 spaces and ended up with a -4. Here you would have plotted 3 points to the left, which was a -3, and then gone to the left 7 spaces. So 1, 2, 3, 4, 5, 6, 7. So you got a -10. Again, -4 tells you 4 spaces to the left. And then even though I'm adding, the negative sign tells me to go left, so I'm adding a -1. So I get a -5. -2 tells me I start 2 spaces to the left of 0. And then because I'm adding that negative tells me to go to the left 2 spaces. So basically this negative undoes this positive. So this left undoes this go to the right. So we end up at a -4. That's going to be really important when we move on to different signs. Now here I have a -6, and it's not on my number line, but I go from 0 to 4, so I know this halfway point is a -2. So each one of these hash marks is worth 2. So here's my -6, because it's 2, 4, 6. And then I'm adding -8. But remember, every time, so I'm adding and going to the left, every time I move, it's worth 2. So this is 2, 4, 6, 8. Well, halfway between -16 and -12 would be -14. And again, to double check, you use the absolute values. I can't stress it enough, ladies and gentlemen, that when you have this negative sign after this positive sign, that it is undoing that plus sign. It's saying, okay, typically when I add, I go to the right, but since this negative is here, it means I'm actually going to go to the left. So think of those negative signs as doing the opposite. All right, I want you to go ahead and try these on your own just by doing absolute values. And when you come back, you can check your answers. So here you should have gotten -9, -10. Then I have 2 plus 8 is 10. Carry the 1. You should have gotten -100. Now, even though there's 3 numbers here, since they have the same sign, I still just add the absolute values and keep the sign. So it ends up being -9 plus a -6 is a -15. -1 and -10 is -11. -90 plus -20 is -110. 5 plus 98 is 203. And then here I have -50 plus a -175. So I have 5 and 0 is 5. 5 and 7 is 12. Carry the 1. I have 225. And then now, so I have a -225 between these two. And I'm going to add a -345. Again, since they're both negative, I can just add them the way that they are. 5 and 5 gives me 0. 2 and 4 gives me 6. And then 3 and 2 gives me 5. But since they're both negative, I get a negative. So you should have gotten -560. All right, so the essential question, How do you add integers with the same sign? What is the process? And this doesn't need to involve the number line, but it could. And I want you to actually tell me when you use the number line, what does it look like? And when you don't use the number line, what does it look like? Then you also had problems that were the your turn problems that we skipped over in your notes. I would like you to also go back and to try these problems on your own. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.